A cycle gamma is an open set. Omega is said to be homologous to 0 with respect to the omega if n gamma is 0 for the all points a in the complement of omega. Now theorem 2, state and prove the general form of Cauchy's theorem. Now statement: if f of z is analytical in omega, then integral over gamma f of z dz is equal to 0 for every cycle gamma which is homologous to 0 in omega. Proof: let us assume that omega is bounded, that otherwise arbitrary, given delta is greater than 0. Let us cover the plane by a net of a sequence of sides delta and let us denote by qj, where j belongs to capital J, and closed squares in the net which are contained in omega. Because omega is bounded, j is finite, and delta is sufficiently small, it is not empty. Then the union of squares of qj, j belongs to capital J, consists of closed rings whose oriented boundaries are made up of the cycles factorial delta is equal to sigma j belongs to capital J delta qj. Clearly, factorial delta is a sum of the oriented line segments which are sides of exactly one of qj. Now let us denote the omega delta in the interior of the qj union of qj. Let us the cycles of homologous to 0 omega. Let us choose the delta so small that gamma is contained in omega delta. Let us consider a point P belongs to omega minus omega delta. It belongs to a list 1 of the Q which is not in a qj. There is a point rho 0 belongs to Q which is not in omega. It is a point to join the P and P rho and rho 0 y line segment which lies in Q, and therefore it does not meet omega delta, since gamma can be considered as a point of the set and contained in omega delta. So it follows that n gamma rho is equal to n gamma rho 0 is equal to 0. In particular, n gamma rho is 0 for small points rho and factorial delta. Suppose now that f is analytical in omega. So if z lies in interior of qj 0, say, then 1 upon 2 pi eta integral over qj f rho d rho over rho minus z is equal to f of z if j is equal to j0 is 0 if j does not equal to j0, and hence f of z is equal to 1 upon 2 pi eta integral over factorial delta f rho d rho over rho minus z. Since both sides are continuous functions of z, this equation will hold for all z in omega delta. As a consequence, we obtain